सर स्टार्ट कीजिए।
In UPSC, the IAS main exam, the chemistry optional, that is having two papers, paper 1 and paper 2. In paper 1, two portions. One is physical chemistry and second is inorganic. But in paper 2, that includes only organic chemistry. So this is the chemistry optional in IAS main. Paper 1, that is physical chemistry and inorganic, both chemistry here in paper 1. And paper 2 itself is totally organic chemistry. Now in physical chemistry, there are most important three chapters: chemical kinetics, thermodynamics, and electrochemistry. More than half question comes from these three chapters. And the rest is solid state, gaseous state, phase rule. These are different, which is less than 50% from where. So the physical chemistry, all the candidates must have a good preparation of electrochemistry, chemical kinetics, and thermodynamics. Inorganic chemistry, here main chapter is atomic structure, chemical bonding, coordination chemistry, and rest is that is bioinorganic or different. But the most important chapter in organic is coordination chemistry. In atomic structure, there is few topics. For example, Schrödinger equation and its application. Second is the uncertainty principle. These 2-3 topics from where question has been asked. But main portion is coordination chemistry, where most of questions comes from these. So in paper 1, the preparation should be targeted or focused on 4-5 chapters. This will cover at least 70% of questions. In paper 2, organic chemistry, here very important chapter is organic mechanism, which is based for the name reaction, reagent, rearrangement, all are based on organic mechanism. This will cover half question. And the next chapter is pericyclic reaction, the photochemistry, and a very important chapter, that is spectroscopy. So I am starting from paper 2 organic chemistry, and here yesterday I have discussed started yesterday, that is from intermediate. And in intermediate, first intermediate is carbocation. And that carbocation, I have already discussed the structure of carbocation. So today the topic is the stability of carbocation. For all the organic reactions, two possibilities. One possibility that the reactant reacts, forms an intermediate and then final product. Second is the reactant that forms directly product. Between these two, there is a transition state. So the second option is this, and first option reactant forms product, and here the intermediate is in between these two. So the among intermediate, I already started studying the carbocation. So now the stability of carbocation, this carbocation, stability of carbocation. Carbocation, I have discussed this. And already I told you that the carbocation is always sp2 hybridized. If it is not hybridized, sp2 hybridized, it means this is very unstable. So for stability of carbocation, there is some important factor. First is the carbocation formed in either in solution or in solid state, and that may be exist in two forms. One is free form, free carbocation like this, and another is in form of ion pair like this. This is ion pair, and ion pair is also named as counter ion or Gigenian ion. So these two names for this is named for ion pair. So the carbocation may be exist in the free form like this or ion pair like this. So ion pair is Gigenian, one name. Another name it is called counter ion, and this is the common name of ion pair. Now, the ion pair is generally exists in non-polar solvents because there is no solvation of ion, so that existing the ion pair forming non-polar solvent. But anyway, the carbocation is formed in any organic reaction as an intermediate. So the formation of carbocation depends on the stability of carbocation. Carbocation, first thing, carbocation is an intermediate, and for any reaction, if intermediate is stable, then large amount of product will form and reaction rate will be high. If intermediate is unstable, then very less amount of product will form and the very low rate of reaction. Simple example, that for simple example, you can imagine if you are hitting someone or clapping someone. Yeah, otherwise you can think as, so you hit someone or did any crime and you are stable at the spot of crime, then you will be caught by many people, or you can say that the your crime is, I think you will be caught by police if you are staying at the spot of crime. So that same case of an intermediate, if this will stable and exist in the medium of reaction, then the count another ion, that is negative ion, that will have maximum time or opportunity to attack here. If this is unstable, so if it is unstable, then this anion will have very less time to attack at this positive charge, and so the reaction will have very low rate and the product will fall in very less amount. So the stability of intermediate or stability of ion, that is very important for organic reaction. So now I am discussing the stability of carbocation. First of stability is stabilization of carbocation by hyperconjugation. Hyperconjugation, we know that the hyperconjugation depends on the number of alpha hydrogen. For example, this is carbocation. So here, this is alpha carbon and these three are called the alpha hydrogen. So the hyperconjugation will act in this way. Look at the picture of this. Here. But this H plus ion always exists in the influence of this pi bond, and it will check influence of this pi bond and it will taken back and go to this. So this is reason I am using here the arrow double-headed. And next is in same way, this is, for example, this is HA, HB, HC. So the one time with HA, in another way, and next form is, these are different hyperconjugation forms. So the presence of 3 alpha hydrogen, that will form the 3 hyperconjugation forms. And a general rule in chemistry that the greater the form of ion or greater the charge delocalization or pairing by different groups, the greater stability of cation. So here hyperconjugation causes the stability sequence of carbocation, that is, look at here, CH3, 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 CH2 plus. This is tertiary carbocation. This is the one carbocation, another this next is CH3, CH2 plus, and the stability sequence is this. Why? Because here alpha hydrogen, number of alpha hydrogen in this carbocation is 9. Here alpha hydrogen 6. Here alpha hydrogen 3. So the number of hyperconjugation, we know that the number of hyperconjugation equal to number of alpha hydrogen, and the greater number of hyperconjugation, greater the stability of ion. So here, this is the reason why this carbocation is more stable than this. This is more stable than this. So this is one factor for the stability of carbocation, that is hyperconjugation. Second factor for the stability of carbocation is inductive effect. Inductive effect. Inductive effect is simply, I am giving a general explanation for inductive effect. Inductive effect is understanding. Here R and carbon having one bonding pair in between these two. This is the normal sigma bond. Inductive effect is if the R is pushing this bonding pair slightly towards carbon. This is slightly towards, not shifting, pushing the sigma bonding pair slightly towards carbon, then this group R is called plus I group and effect is called plus I effect. Another example is if R is pulling bonding pair towards itself. Here one thing I missed you tell. During this pushing the bonding pair towards carbon, then this group gets delta positive charge, slightly polarized charge, and here delta negative. In second case, if the bonding pair is slightly pulling by R towards itself, means away from carbon, then here gets delta positive, here gets delta negative, and this is called minus I effect, and this group is called minus I group. So that this is inductive effect. Now imagine that this is carbocation, and here any group, this A, that is plus I group. So if A is plus I group, it means pushing the bonding pair slightly towards carbon, which causes decrease in charge density, positive charge density at carbon, that is decreased due to slightly shifting this bonding pair towards carbon. And in chemistry, a general rule, that is, lesser the charge density, greater the stability of ion. So the plus I effect that will pushing the bonding pair towards carbon, that cause decrease in charge density at carbon. It means increasing the stability of carbon. This is the reason why this is tertiary carbocation. This is more stable than this. Secondary is more stable than this. This is primary. Here, number of plus I group in this case 3, in this case 2, and in this case 1. So the here greater number of plus I group, which results to greater plus I effect on this carbon, and which causes decreasing large amount of charge density at this carbon, and this is the reason why this tertiary carbocation is very stable. Here 2 plus I group, so the charge density decreases here lesser than tertiary, because here 3 plus I, here 2 plus I, and here plus 1. So the presence of plus I group at the positively charged carbon, which causes decreasing the charge density at carbon, and which results to the greater stability of carbocation. So the large number of plus I group at the positively charged carbon, larger the stability of carbocation. However, reverse in the case of presence of minus I. Presence of minus I group, imagine this carbocation, and here is fluorine. So the fluorine is more electronegative than carbon. So the more electronegative fluorine, that will pull the bonding pair towards itself. So the shifting of this bonding pair more towards fluorine means it is not localized exactly between carbon and fluorine. So the here minus I effect of fluorine. So the due to this minus I effect of fluorine, increasing the charge density of carbon, because here already positive charge, and this bonding pair shifting more towards fluorine, it means here charge density increases. And I told you that the decreasing the charge density, increasing the stability. If charge density is increased, then stability will decrease. So this is the reason why this carbocation is less stable than methyl carbocation. So the presence of plus I2 that will increase the stability of carbocation, and presence of minus I group that will decrease the stability of carbocation. One thing is important, that the chemistry optional does not require only English language. You can write it in Hindi. हिंदी के लिखने का तरीका ये है कि हम लिखेंगे हाइपर कंजुगेशन, जैसे अभी हमने कहा इंडक्टिव इफेक्ट, तो तुम लिखोगे इंडक्टिव इफेक्ट, ऐसे लिखोगे कि इंडक्टिव इफेक्ट में प्लस आई इफेक्ट किसी भी ग्रुप का माइनस आई इफेक्ट होने से चार्ज डेंसिटी कार्बन पर बढ़ेगा और स्टेबिलिटी घटेगा। वहीं प्लस आई इफेक्ट होने से कार्बन पर चार्ज डेंसिटी घटेगा तो स्टेबिलिटी बढ़ेगा। मतलब जो टर्म है उसको इंग्लिश में लिख सकते हो, बाकी चीज हिंदी लैंग्वेज में। तो ये कंफ्यूजन दिमाग में मत रखो कि केमिस्ट्री लेना होगा तो इंग्लिश में ही लिखना होगा। मैंने देखा है कि बहुत सारे मेरे स्टूडेंट IITians थे और वो हिंदी मीडियम में केमिस्ट्री लिख के बहुत अच्छे नंबर लाते, और मैं उन्हीं से सीखा। जब वो लोग मार्कशीट दिखाया और बोला कि सर मैंने तो हिंदी में लिखा था, मैंने कहा कैसे लिखे थे, लिख के दिखाओ। और तब मैं सीखा उनसे कि हिंदी मीडियम में बहुत अच्छे नंबर आते हैं, क्योंकि हिंदी मीडियम के जो कॉपी होते हैं केमिस्ट्री के, वो नॉर्थ इंडिया में ही इवेलुएट होता है, क्योंकि नॉर्थ इंडियन प्रोफेसर उसे हिंदी मीडियम जानते हैं। लेकिन इंग्लिश मीडियम के जो कॉपी होते हैं वो मोस्टली साउथ इंडिया जाते, इसके वजह से ये डिफरेंस आता है लैंग्वेज। एनीवे यू कैन राइट केमिस्ट्री इन आइदर हिंदी और इंग्लिश, बट डोंट ट्राई टू राइट द एग्जैक्ट हिंदी नेम ऑफ इंडक्टिव इफेक्ट, इट इज नॉट पॉसिबल। टर्म जो है वो टर्म को तुम इंग्लिश में लिख सकते हो, बाकी चीज हिंदी। Now the second factor of the stability of carbocation, that is the stabilization. Third factor, stabilization by conjugated pi bond. Conjugated pi bond. This is also a big factor to stabilize the carbocation. For example, we know that So this carbocation, here this pi bond is conjugated and this is more stable than this carbocation. Here no pi bond at conjugation, so that this is less stable. Here pi bond is at conjugation, so this is very stable. Reason is, look here, this is your carbocation, and right at one thing is very important in chemistry, that is the writing technique. If you have good writing technique, then you will get the maximum mark, because this is science. So the use of arrow, very important, that starts from origin. This pi bond moving from here to here, so that this bonding pair, pi bonding pair, moving from here to here, so use the arrow from here to here, and writing the resonance, use this symbol, and this. And very important thing, neither this is existing nor this. So write the hybrid structure in this way, using 3 parallel lines. And now the important thing, use here the dot from where to where positive charge is moving. So the positive charge moving from here to here means use the dot from here to here, write this. This is called delocalization of positive charge. So the delocalization of positive charge. तुम जानते हो कोई भी क्रिमिनल इफ हैज मेनी हाइडआउट, किसी भी क्रिमिनल को बहुत सारे छिपने की जगह हो, तो देन इट इज वेरी डिफिकल्ट फॉर पुलिस टू कैच हिम. तो पुलिस को बहुत प्रॉब्लम होती है कि उसे पकड़े कैसे. तो मान लो कि ये क्रिमिनल है और पुलिस कोई आ गया, मान लो कि निगेटिव आयन, तो दिस निगेटिव आयन will try to add at the positive ion. So initially positive was there, this carbon. अगर ये X this positive charge moved, this positive charge moved from here to here, means X could not combine immediately at here because the positive charge moving from here to here. ये जो क्रिमिनल था पॉजिटिव चार्ज, और X जो पुलिस इसे पकड़ना चाहता था, तो जब ही ये पकड़ने के लिए आया, दैट विल मूव फ्रॉम हियर टू हियर, दूसरे जगह. इट हाइड आउट एट सेकंड प्लेस. यहाँ फिर X ट्राई करेगा यहाँ जुड़ने के लिए, then this positive charge go back to here. मतलब delocalization of positive charge. तो इसका मतलब क्या है कि X को ज्यादा टाइम लगेगा, X will take more time to add at a particular carbon. इसका मतलब क्या होगा? It means the stability of this carbocation is greater than this because here no delocalization of charge. So the greater the delocalization of charge, greater the stability of cation. For simple example, this carbocation. Here 1 and 2, two conjugated pi bond. इसका मतलब है कि यहाँ जो डीलोकलाइजेशन होगा दैट विल लुक एट and again it will move. This, it means here delocalization of the positive charge in larger area. So this is the reason why this carbocation is more stable than this. So here this carbocation is more stable than this because here larger delocalization than this. So the conjugated pi bond will increase the stability of carbocation by the delocalization of positive charge, which causes greater the stability of carbocation. So greater the delocalization, greater the stability of carbocation. Now the next factor is the stabilization by aromatic ring. For this stabilization by aromatic ring. This, we know that the benzyl carbocation, this is benzyl carbocation, this is very stable. So the how this is very stable. This is aromatic ring which present at the carbon which is positively charged. So this is the largest stable carbocation. How? So here large delocalization of positive charge. Look at it. So the here hybrid structure is this is the hybrid structure. It means presence of one benzene ring at this carbon which causes the delocalization of charges in large area. So, and formation of three canonical forms. Canonical form 1, 2, and 3. And delocalization among 1, 2, 3, 4, 5, 6, 7. 7 कार्बन, इस 7 कार्बन के एरिया में this positive charge is spreading. It means here charge is spreading in large area. It means stability will be very large. मैथमेटिकली तुम कैलकुलेट करके कह सकते हो कि 1 positive charge at this carbon that going at second, third, this is third and fourth carbon. तो मैथमेटिकली अगर ऐसे भी जोड़ो तो 1 positive charge that is speeding at 4 carbon, it means 1 carbon having 0.25 positive charge. So the large spreading of charge with delocalization of charge. अब एक कार्बन पर 1/4 चार्ज बचा. It means spreading of charge, charge फैला बहुत ज्यादा, and 1 carbon now belongs to 0.2.5 positive charge. Means this carbocation is very, very stable. So the 2 factors here operating. One is the delocalization, second is spreading the charge. एंड यहाँ पर एक चीज गौर करो, गौर करने की ये है कि अगर बेंजीन रिंग पर कोई प्लस आई ग्रुप हो, यहाँ कम थोड़ा सा इमेजिन करो, देखो यहाँ गौर कर रहे हो, बॉन्डिंग पेयर इज मूविंग फ्रॉम रिंग टू आर here between these 2 carbon. तो इसके मूवमेंट को इन्फोर्स करेगा अगर मान लो कि कोई प्लस आई ग्रुप होता, वो क्या करेगा, सपोर्ट करेगा मूवमेंट को. लेकिन अगर कोई माइनस आई ग्रुप हो लाइक फ्लोरीन, तो करेगा क्या, ये जो मूवमेंट है इलेक्ट्रॉन को उसको विड्रॉ करेगा, पीछे तरफ खींचेगा, एंड दैट विल नॉट इनकरेज मोर और सपोर्ट दिस टाइप ऑफ डीलोकलाइजेशन. तो प्लस आई ग्रुप है एट द रिंग, दैट मेक्स मोर स्टेबल कार्बोकैटायन देन माइनस आई ग्रुप एट द रिंग. Now here second thing, if the presence of 3 benzene rings like this is called triphenyl methyl carbocation is more stable than this. This is diphenyl carbocation, and this is more stable than benzyl carbocation. Reason is the here three being that will, हमने अभी देखा है, we have seen just before, कि हमने देखा है कि when one being is present, then it will form the three canonical forms. Two means six canonical forms, and here three, it means 9 canonical forms. So the larger number of canonical forms means larger the delocalization of charge. This is the reason why this is more stable than this. This is more stable than this. Means canonical form, number of canonical form, ये इसके केस में 9, इसके केस में 6, and in this case 3. And this is the reason why this is more stable than this. This is more stable than this. Now, here one question is very important. See, we know that the carbocation having a structure triangular and shape is triangular planar. Planar means all the three groups at the positively charged carbon are present in the same plane. Now here very important question. Is the benzene ring having large size and three rings present within a plane, that will cause very large intramolecular strain. होता है कि नहीं, ये छोटे से कमरे हैं जहां 10 आदमी खड़ा हो सकता है, और वहां अगर 20 घुसा दे तो दैट विल कॉज द स्ट्रेन. टेंशन होगा, एक दूसरे को हिट करेगा, ये कुछ करेगा, दैट विल कॉज द प्रॉब्लम. तो उसी को कहते हैं स्ट्रेन. यहाँ एक ही प्लेन में 3 बेंजीन रिंग है, तो दैट विल हैव लार्ज इंट्रामोलिकुलर स्ट्रेन. So the question is here, यहाँ जो क्वेश्चन है that is कि क्यों, why this is very stable कार्बोकेटायन, बहुत ही स्टेबल क्यों है? The reason is that explanation is this stability. तो ये जो है कार्बोकेटायन that will take the propeller से कोई चीज फेंको, थ्रो करो, तो प्रोपेलर ऐसे शेप बनाता है, तो ये प्रोपेलर शेप गेन कर लेता है. दैट विल कॉज डिक्रीजिंग लार्जली द इंट्रामोलिकुलर स्ट्रेन. वो जो टेंशन था ज्यादा क्राउडिंग का, वो कम हो जाता है. क्या है प्रोपेलर से? बाकी तो जरा गौर करो. देखो इसे गौर से. हेक्सागोनल स्ट्रक्चर नहीं रहता, ऐसे खींच जाता है. दैट मीन्स जस्ट लाइक दिस. ठीक है. अब देखो पाई इलेक्ट्रॉन का जो है लोकलाइजेशन, इधर ज्यादा है पाई इलेक्ट्रॉन, इस साइड कम है. अब इधर कम है तो यहाँ इधर ज्यादा होगा. दिस एरिया विल हैव लार्जर डेंसिटी ऑफ पाई इलेक्ट्रॉन and this area having less. In same case here, the larger density of pi electron and this area having less. Now this is the propeller. And taking this propeller shape, now this carbocation becomes very stable. क्योंकि प्रोपेलर से पकड़ने के बाद that when it will take the propeller shape, intramolecular strain decrease largely. So the stabilization by aromatic ring. Now next topic, stabilization factor. Stabilization by cyclopropyl ring. Stabilization by cyclopropyl ring. Look at here. This is cyclopropyl. So the presence of plus cyclopropyl ring at the positively charged carbon, that will increase the stability of carbocation. And look at here, dicyclopropyl here, this is more stable than 1-propyl, and this is more stable than this. तो यहाँ पर है here very surprising result. रिजल्ट ये है कि हाउ यहाँ पर साइक्लोप्रोपाइल भी there not any conjugated pi bond, so that it will provide the resonance stabilization. So how this cyclopropyl gene stabilizes the carbocation? So the explanation is, look it seriously and think about this. We know that this cyclopropyl having here angle 60 degree, 60 degree and 60 degree. You know that all these three carbons are sp3 hybridized. And we also know that in case of sp3 hybridization, bond angle is 109. So from 109, how it is possible that the holding the angle from 109 to 60 degrees? So practically it is not possible. So real bond direction, in this case, this is the false line. The real bond direction is in this way. This is the real direction of bond. This is the false line. And we can write it the orbital picture here. Look here. PS2 positive. Here one p orbital from the carbocation structure. We know that this p orbital is vacant. Vacant p orbital. This is, and here the carbon having the bond is one here sigma bonding pair for this. Another is this and this. This bond, this bond, this bond, like this. So here, this is the scene here for this orbital picture like this. Now here, this is the, look here, this is the, here, this may be written as the side by side interaction of vacant p orbital with filled two sigma bonding pair. This side by side interaction, not the overlap. Word पर ध्यान दो. I am telling here interaction, not the overlap. Yes, side by side interaction of the vacant p orbital of that carbon having positive charge with the two sigma bonding pair. That results to large decrease in charge density of carbon. क्योंकि एक p ऑर्बिटल को दो ही इलेक्ट्रॉन चाहिए, यहाँ 4 इलेक्ट्रॉन से इंटरेक्शन होगा. क्या होगा? That will cause large density, large decrease in charge density of this carbon, this positive charge. And we know that the decrease in charge density in large amount, stability of ion will increase large. So the one explanation is this. Second explanation for the high stability provided by cyclopropyl D is the sigma conjugation. Sigma conjugation, देखो इसे गौर से. This sigma bond is conjugated with this positive charge, and sigma conjugation will work in this way. इसे गौर से देखना. Which causes the delocalization of positive charge. So the another big factor here of rating, that is the sigma conjugation. Sigma conjugation, and which will provide the largest stability of carbocation. So कई बार ये IAS के एग्जाम में पूछ चुका है क्वेश्चन कि देखो CS2 cyclopropyl methyl carbocation is more stable than this. Again, CS this is more stable than, ये पूछ चुका है क्वेश्चन. And ये IAS के एग्जाम में पूछा हुआ क्वेश्चन है, एक दो बार नहीं कई बार, मेनी टाइम्स दिस क्वेश्चन हैज बीन आस्क्ड. तो देखो, one cyclopropyl being will stabilize more than one phenyl being. Two cyclopropyl will more stabilize than two phenyl being. Three more stabilized than three phenyl group. Reason quite clear. If the phenyl group present at the positively charged carbon, due to large size of phenyl group, that will causes the intramolecular stain. But in case of cyclopropyl gene having very small size, that will not create more stain. First explanation. Secondly, the pi conjugation that will provide the resonance stabilization. The same effect here also. The sigma conjugation that will provide the resonance stabilization. Third thing, here no charge. Here the large decrease in charge density is due to the side-by-side interaction of vacate p orbital of carbon and the bend filled sigma orbital of cyclopropyl gene, जो अभी हमने डिस्कस किया. But here such types of interaction is not available. So the here charge density decreasing by side-by-side interaction is absent. So the two different important factors, less strength and side-by-side interaction, causes decrease in charge density. Here more strength and no side-by-side interaction. So this question has been asked many times in the IAS exam. Now next factor is stabilization. Stabilization by lone pair of electrons. Lone pair of electrons. that for check and one example. Here are two groups having lone pair of electrons at nitrogen that will provide this type of delocalization of positive charge, and which causes you should write hybrid structure like this. So here delocalization of positive charge due to lone pair of electron which is present at the adjacent atom. So delocalization of charge, stabilization of carbocation. Now next factor is the stabilization by aromaticity. Stabilization by aromaticity. देखो ये डिस्कस करेंगे हम एरोमेटिसिटी चैप्टर में कि एरोमेटिसिटी हाउ इट विल प्रोवाइड, एरोमेटिसिटी का मतलब क्या होता है। बेसिकली एरोमेटिसिटी का मतलब होता है, मीनिंग ऑफ एरोमेटिसिटी कि द मॉलिक्यूल व्हिच गेट्स द एक्स्ट्राऑर्डिनरी स्टेबिलिटी that is called aromatic. अब चूंकि if a carbocation is getting aromaticity, it means that carbocation is very stable. For example, the example is this carbocation. This is very stable carbocation. Why? Because it gets aromaticity. So, if a carbocation gets the aromatic character, then it is very stable. So, we know that the aromatic compound is very stable. It will not react easily. It is a stable molecule. And if a carbocation gets its aromatic character, then it is very stable. हम चर्चा करेंगे when we will discuss the topic of aromaticity, तो वहाँ समझाएंगे कि what are the criteria or characteristics of aromaticity. क्योंकि यहाँ वो इशू नहीं है, यहाँ सिंपली इतना जानो कि when a carbocation gets aromaticity, gets aromatic characteristics, then it is very stable. So that this carbocation is very stable. Then देखो, for example, this carbocation, तो जनरल लोग कह देता है कि here 3 conjugated pi bond. This is the reason why this is more stable than this, because here 2 conjugated pi bond. लेकिन जो मोस्ट इम्पोर्टेंट फैक्टर है वो है एरोमेटिसिटी, क्योंकि दिस गेट्स एरोमेटिक, दिस इज एरोमेटिक, दिस इज नॉट एरोमेटिक. So another factor, that is the stability of carbocation due to aromaticity. Now another stabilization factor, that is stabilization by non-conjugated pi bond. अभी हमने तो conjugation की बात किया था. We have discussed about conjugation. Now here I raise the question of non-conjugated pi bond, and that is providing the stabilization. How? Example देखो, हम यहाँ चर्चा कर रहे हैं. One second. देखो, this is very stable carbocation, and this is very stable carbocation. However, this carbon having positive charge, so the here pi bond, that will be conjugated pi bond, but pi bond is not here, that is here. So how this will provide the largest? हमने अभी कहा है कि stabilization by non-conjugated pi. So reason is this. So the here delocalization of positive charge like this. लेकिन हमने देखा था कि pi bond is providing stabilization when it is at the conjugated position. But how this stabilization is possible? तो जरा हम गौर करें. We should look at the orbital picture of this molecule, this carbocation. मैं दिखाना चाहूंगा ऑर्बिटल पिक्चर. Look here. Here pi bond. यहाँ पर pi bond है. इसको कैसे लिखेंगे? ऐसे लिखते हैं. यहाँ एक पेयर इलेक्ट्रॉन का है. And here is the vacant p orbital which having positive charge. And look here. गौर करो here. Here these two orbitals are along the axis. एक ही एक्सिस पर है both. So that will cause this overlap, and this pi electron going in between these two. This is the reason why this structure is formed. ये जो बना वो इस वजह से, because these two p orbitals along the axis, so that this pi bonding pair will involve in this sigma bonding, और ये sigma bond बन जाता है. Now this carbon loses electron, to this carbon-based positive charge. देखो हमेशा यूपीएससी के एग्जाम में you must have to focus on unique, not the general, क्योंकि क्वेश्चन जनरल नहीं होता, जो यूनिक होता है वही पूछा जाता है। जैसे कि हमने कहा कि साइक्लोप्रोपाइल बी प्रोवाइडिंग ग्रेटर स्टेबिलिटी देन फिनाइल बी, तो कई बार पूछ चुका है। एंड लोगों को कंफ्यूजन होता था कि सर ये पढ़ाते हैं और वही क्वेश्चन आता है, इसका मतलब है कि सर है क्वेश्चन सेटर, लेकिन ऐसा नहीं है। मेरा व्यू है कि हमेशा यूनिकनेस पर ध्यान दो। Now the generation of carbocation. Generation of carbocation. There is three ways. One is the heterocyclic bond cleavage. जैसे देखो, if here one group that will leave without bonding, with bonding pair, leave bonding pair, which will form the carbocation. This is the heterocyclic bond cleavage. So this is the one process of generation of carbocation. So the heterocyclic bond cleavage, where one leaving group from the carbon leaves with bonding pair, which causes generation of carbocation. Second is addition of a cation on pi bond. This is process. For example, देखो ये pi bond है, where addition of a cation, मान लो H plus जोड़ में, एरो का यूज ध्यान देना। That this is the second way to generate the carbocation. इसका मतलब है कहीं पर भी pi bond हो, any place the pi bond is present, adding there any positive ion, the result will be carbocation. Now third is oxidation of free radical. कोई फ्री रेडिकल है, देखो यहाँ, एंड ये एक इलेक्ट्रॉन ले गया यहाँ से, तो दैट विल फॉर्म द कार्बोकैटायन. देखो ऑर्गेनिक रिएक्शन लिखते समय, ड्यूरिंग राइटिंग द ऑर्गेनिक रिएक्शन, यू मस्ट हैव कीप इन माइंड दैट द कोई भी ग्रुप, एनी लिविंग ग्रुप, दैट शुड राइट लोअर द एरो, or adding group always write above the arrow. This is the correct technique. If you are writing in another way, that will be wrong and you will not get any mark. Now, the reaction, types of reaction, type of reaction of carbocation. First is addition reaction. This is of two types. Addition with anion. जैसे देखो, this is carbocation and if it will add with anion, तो anion electron x पर है, तो arrow ऐसे use कर, and that will form R. arrow ऐसे use करना है, क्योंकि x से जो पेयर है इलेक्ट्रॉन का वो R तरफ जाता है. Here, that this will result to the formation of this sigma bond and result to क्या होगा है? The result is the neutral molecule. Second is addition का दो पार्ट है. Second is addition on pi bond. pi bond पर देखो तो this and कोई भी कार्बोकेशन है pi bond पर ऐड होगा. एरो ध्यान देना. this ये दो टाइप का एडिशन हैविंग टू टाइप. यहाँ पर क्या हो गया? यहाँ था न्यूट्रल फॉर्मेशन ऑफ न्यूट्रल मॉलिक्यूल. यहाँ क्या हो गया? फॉर्मेशन ऑफ अनदर कार्बोकेशन. नेक्स्ट इज सेकंड इज एलिमिनेशन रिएक्शन. देखो कोई कार्बोकेटायन है, फॉर एग्जांपल दिस कार्बोकेटायन, here any group that can live without bonding pair, तो then क्या होगा? here formation of a neutral molecule but that will be unsaturated. क्या होगा? कोई लिविंग ग्रुप that will live without bonding pair. तो यहाँ H बिना bonding pair का H plus E plus, and this bonding pair involved in pi bond formation between these two carbon. Results will be neutral molecule and the now third type is rearrangement. This type of reaction. देखो यहाँ पर this is very simple. यहाँ PH है, PH2 प्लस, तो यहाँ rearrangement हो सकता है and which causes to formation of this carbocation. This is more stable than this. So the by rearrangement we will get more stable carbocation from less stable, and this is called rearrangement. Means one carbocation rearranges another carbon. Fourth is reduction reaction. Reduction reaction. This देखो R plus आयन है, that will reduce half arrow. एक इलेक्ट्रॉन के मूवमेंट को हाफ एरो से लिखते हैं, लाइक दिस. दिस इज हाफ एरो. दिस रिप्रेजेंट द मूवमेंट ऑफ वन इलेक्ट्रॉन. इफ यू आर यूजिंग full arrow, means movement of two arrows. So the now here formation of free radical. So these four types of reactions which are given by carbocation. So the firstly in yesterday class I have already discussed that the carbocation definition that is given by different author and teacher, which is completely wrong. So there in yesterday class I have explained the carbocation is the positively charged hydrocarbon. That is called carbocation. In that class, I have explained the now carbocation. Among carbocation, one is carbonium and another carbenium. Here, look here. This suffix ONIUM. Ammonium, ONIUM. Hydronium, look at these suffix. तो हाइड्रोनियम में क्या लिखते हैं? Here H3O plus. This is hydronium. Ammonium NH4 plus. इसका मतलब है कि कार्बोनियम CH5 plus. CH5 plus. देख रहे हैं नोमेनक्लेचर से? हाइड्रोनियम, अमोनियम, कार्बोनियम, CH5 plus, and carbenium, this is +1 because ENIUM, IUM for positive charge or EN for lesser valence than normal. So this is carbene. What maximum carbocation is existed, that is CH3 plus type, means carbenium type. This is the reason why many global level authors, not Indian authors, because Indian author is completely confused and they are writing always wrong. So I have told you that never use any Indian author if you are willing to get qualified in UPSC, not a single Indian author. So the global author most of them is using CH3 plus type ion, which is carbenium, as a carbocation. So, and the structure, I have already told you that here the hybridization is sp2, and here hybridization is sp3. So in valence shell, here the electron is 8, here valence shell, electron is 6. Carbonium is tetrahedral, this is triangular. Shape for carbonium is tetrahedral, for carbenium shape is triangular planar. So these are the difference, and I had already explained these things and the structure of carbocation in yesterday class. Today I have discussed the stability, generation and reaction. Tomorrow I will discuss about the carbanion, means negatively charged hydrocarbon. Okay. Now concluding, and tomorrow I will teach you or discuss you the carbanion.